Daniel wants to make a simple toy box. He has a single sheet of standard plywood. Making only 4 cuts, shown here, 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 and here. Where should he make the cuts to maximize the volume? A standard sheet of plywood is 4 feet by 8 feet. It's also 96 inches by 48 inches. Daniel needs to make the cuts approximately here, 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 and here. These 4 corners will be discarded, leaving only these 4 pieces as the side and this as the bottom. We don't know how wide these cuts need to be made yet, but this distance here and here we can call x. We can call this x as well because when the box is made, the 2 sides will be joined together, and since all 4 sides need to have the same height, when these get cut, they need to form a nice clean edge right at the corner. So can we write a formula that expresses the volume of this box? We know that in general, the volume of the box is equal to its length times width times height. A height here, length here, and width here. So if this is our box, our length is going to be this distance minus our 2x distances. We have 96 inches minus x and minus another x. So this is 96 minus 2x. Our width, very similar, it's 4 feet, 48 inches, minus an x minus an x. That equals 48 minus 2x. And our height is just x. Now that we have our length, width, and height formulas, we can put them together into a volume equation, use calculus, and maximize it. So volume is equal to 96 minus 2x times 48 minus 2x times x. Using our FOIL method, we get the first terms, 96 times 48 is equal to 4,608. The outer terms, negative 2 times 96 is 192, so that's negative 192x. Our inner terms, negative 2x times 48 gives us minus 96x. Negative 2x times negative 2x gives us positive 4x. And this is just the first 2 binomials. We still have the x term on the outside. Combining like terms in the middle, we get negative 288x plus 4x squared. Forgot the squared. 4,608 all has an x on the outside. And distributing the x to the inside, we get 4,608x minus 288x squared plus 4x to the third. This is our volume equation with respect to x. So now the next step in this process is to differentiate so that we can set it equal to 0 and solve for x. So v prime of x is going to equal 4,608 minus 576x plus 12x squared. Now we can set this equal to 0 and solve for x. The next step is to use the quadratic formula to solve for the zeros. I can make it a little bit easier on myself. Each of these terms has a factor of 12 in them, so if I factor out of 12 out of 4,608, I get 384 minus 48x plus x squared, all equals 0. And if we divide both sides by 12, we get the 12 on the left side can cancel. So I'm left with x equals the opposite of negative 48 plus or minus the square root of negative 48 squared minus 4 times 1 times 384 all divided by 2 times 1. When we plug this monster into our calculator, we get two values of x. First value is 10.1436. The second value is 37.856. So which one of these two makes sense? If we pick the second one, x is measured this distance away from the edge. The whole piece of plywood is 96 inches wide, from here all the way out to here. 37 inches comes a little bit shy of halfway. If we cut all the way through, that's not going to be ideal because that's not how we want to build our box. Turns out that 10 inches, 0.14 inches, makes up this distance here. And it will give us a nice cut along here, 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 and here. So the overall height of the box is 10.14 inches. So what's the length and width? The length was equal to 96 minus 2x. So 96 minus 2 times 10.14, which equals 75.713. 75.713. And our width was equal to 48 minus 2 times x, which equals 27.7. These will be the overall dimensions of the box that has the maximum volume from a single sheet of plywood.